Okay, this is the Chapter 11 Most Missed Questions on the Exam. And before we get into this chapter exam review, I want to go over a concept called relevant range. Here we have a pizza company called 54 Pizza. And what we have is a graph of their oven costs, and an oven is a fixed cost. That is, once you buy the oven, you are now trying to make pizzas with it. And what this graph shows is the following. They're currently operating at 40 pizzas per hour, and this graph shows along the bottom here how many pizzas they can make per hour, and over on the left hand side it shows the cost for each oven that they're going to have. For example, if they had one oven, they can make anywhere from 0 up to 100 pizzas an hour, and that oven cost them $80,000. If they had two ovens, they could go all the way up to, looks like, 200 pizzas per hour, or they could double their production. But if they did, that would also double their fixed cost from $80,000 all the way up to $140,000. And if they had three ovens, they could go all the way up to 300 pizzas an hour, or triple their production. And of course that would cost them another, let's see, $140 all the way up to $220,000, so, or up to $200,000 rather, so another $60,000. These ovens cost $60,000 a piece. So what you can see is that these ovens are a fixed cost as long as, and they don't change as long as they get to a certain, when they get to a certain level, then if you want more production, you're going to have to buy more ovens. Now, so if they're currently operating at 40 pizzas per hour, the next question is, can they go from 40 pizzas per hour up to 80 pizzas per hour within their current relevant range of activity? Well, yes, the answer is yes, because this first pizza that they're making pizzas with, if they're at 40 an hour, which is right in here, yeah, they can go all the way up to 100 pizzas and still be within the relevant range of the fixed cost of this oven. So the moral of the story is, within the relevant range, fixed costs don't change. Let me repeat that. Within the relevant range, fixed costs don't change. Okay, so we have a company here called XYZ. They incurred $131,200 worth of fixed cost and $147,600 worth of variable cost when 3,600 units of product were made and sold. If the company doubles volume within the relevant range, there you go, that's the key thing right there, they're still within the relevant range even when they doubled their volume, the total cost will be what? Okay, so their current cost per unit is going to be something called total cost per unit, which is made up of two things, fixed cost and variable cost. And we're going to add those together and divide by the number of units to get their current cost. So their current cost are their fixed cost of $131,200 and their variable cost of $147,600. We're going to add those together and divide by their current units of production, or their current units, which are 3,600, and this will give us $77.44. So when they double volume, still within the relevant range, fixed costs won't change. So what we have then is $131,200 fixed cost plus 2 times the variable cost, because the variable costs do change. They go up and down in direct proportion to how many units you make. So if you've doubled your units, you're going to double your variable cost. So we'll have $131,200, which is fixed, plus the variable, which is $147,600 times 2 times twice as much volume, divided by the twice as many units, which is 3,600 units times 2, and this will be fixed cost the same, $131,200, plus $295,200 worth of variable cost divided by 7,200 units, and that means that our total unit cost will now be $59.22 per unit. It was $77.44, now it's $59.22. The moral of this story is, is that since fixed cost didn't change when you doubled volume, you are now spreading your cost over more units. Therefore, the total cost is going to come down some. Okay, our next problem says for the last 2 years, XYZ company had the following net income as follows. They've got net income in year 1 of $89,000. Net income in year 2 was $109,000. So they want to know what is the percentage change in income from year 1 to year 2. Now, we've got a little formula we use, which is the percentage of change is equal to the analysis year, which is year 2, minus the base year, which is year 1, and that difference is going to be divided by the base year, which is year 1. Now, here's a rule that you don't forget. If the base year on any of these calculations like this where you're trying to find a percentage change, if the base year is 0 or it's negative, the calculation can't be made. But it's not 0 or negative. So we'll have 109, which is year 2, minus year 1, 89,000, and that difference will then be divided by year 1 to come up with our percentage of change, or in this case it'll be a percentage of increase. And that means that we had a $20,000 increase from years 1 net income to year 2's. We divide that by the year 1 or base year of 89,000, and that means that percentage-wise we increased our income from year 1 to year 2 by 22.47%. Okay, our next question wants to know what is the company's magnitude of operating leverage, and they give us sales revenue. Looks like it's going to be 2,900 units times the selling price of $20.40 per unit. Give us $59,160. They also give us the cost of goods sold, and they give it to us in 2 pieces. A variable cost of goods sold, which would be like materials and labor. This is 2,900 units times $10.40 per unit, which is $30,160. And they also give us the cost of goods sold that are fixed costs. That would be like rent or depreciation, and that looks like it's going to be $4,400. Then they also give us the gross margin, which is the difference between the sales minus the cost of goods sold, which is $24,600. And then the expenses, which would be administrative salaries, $6,400. Depreciation, again below the cost of goods sold line, $5,400. And supplies, which is another variable cost of 2,900 units times $240 per unit. It's a expense that amounts to $6,960, and then all of these things come up to a net income of $5,840. Now, in this problem, if we're trying to find out the magnitude of operating leverage or the degree of operating leverage, another way to say that, another way to say it would be how much operating leverage does this company currently have with this structure. You're going to find that by step 1, finding the contribution margin. And the contribution margin is simply the revenues minus variable expenses. So in this case, we have revenues of $59,160. We have variable expenses. We have 2 variable expenses up above. We've got the cost of goods sold that was variable cost, $30,160 right up here. And we also have the $6,960, which are the supplies that were variable. That is, they go up and down when volume goes up and down. Now, when you run this through your calculator, what you end up getting is a contribution margin of $22,040. Now, this contribution margin is what you're going to need to come up with how much operating leverage we have. And the operating leverage formula is going to be contribution margin, which is $22,040, divided by net income, which is $5,840. Now, when you do that, you end up with a operating leverage right now of 3.77. That is the $22,040 contribution margin divided by the net income of $5,840, which is operating leverage of 3.77. That means this. That means that every time you raise your revenue $1, you're going to go up $3.77 in net income. So just think about that. Every time you get your revenue up $1 more, that gives you $3.77 worth of profit. on the bottom line. Now, let me repeat that. So what does operating leverage mean? It means the degree to which a firm or project can increase operating income by increasing revenue. So once again, if the current leverage is 3.77, that means they can raise their revenue $1 and get $3.77 in profit for doing that. Now, that's a pretty good degree of leverage. And just to keep this in mind, the higher portion of fixed cost in a production process means that the operating leverage is higher, which means this must be a higher total fixed cost. And that means that if you have higher operating leverage, that means the company has more business risk, because they got to keep those volumes high in order to cover those fixed costs and again make that kind of profit. In this problem, they give us sales revenue of $44,640, variable costs of $19,840, which is based on sales of 3,100 units. See that? Fixed costs are $9,400, and net income is going to be the sales minus the variable cost here, minus the fixed cost of ends up being $15,400. So we're taking revenues minus variable and fixed costs to come up with net income of $15,400. The question they want to answer is, what is XYZ Company's magnitude of operating leverage? We said that operating leverage is figured by taking contribution margin and dividing by net income. Well, we've got net income of $15,400, and we can figure out contribution margin because contribution margin is just simply sales minus variable costs. So our contribution margin will be $44,640 minus $19,840, and that's divided by our net income of $15,400. So that means that our contribution margin is $24,800, and we're divided that by $15,400, which is our net income, and our operating leverage is 1.61. Now I'm going to go a little further than just stopping right there. That's the answer we would want to get, was 1.61. So that means for every time we raise revenue $1, we're going to raise our income by $1.61. So let's go. I'm going to show you another example here. I'm going to flip-flop variable and fixed cost. I'm going to have a company called ABC Company, and I'm going to have the same revenue, $44,640, and yet I'm going to say now I'm going to say that the variable costs are now $9,400, which is what we had before in our other example. That was our fixed cost. And I'm going to say that our fixed costs are $19,840. So I've just flip-flopped these around, which means in this example I've got more fixed costs. And of course our income's the same, which is $15,400. Now, what would you suspect would happen here when I do this? Would you say that XYZ Company's operating leverage, which is 1.61, would you say that's going to be higher or lower than ABC Company's operating leverage? And we said in an earlier example that the more fixed cost you have in your structure, in this case we flip-flop them, and now ABC has more fixed cost, that means they're going to have a higher operating leverage. So let's see if that's the case. So our contribution margin divided by net income is going to be the $44,640 revenues minus the $9,400 worth of variable cost, and that's going to be divided, that's sum, and then it's going to be divided by $15,400, which is net income. So now we're going to have contribution margin of $35,240 divided by $15,400, and our operating leverage, of course, is higher because we have more fixed cost in this structure, which is 2.29. And again, the moral of the story is the higher portion of fixed costs you have in your production process means that the operating leverage is going to be higher, and the more operating leverage you have means that you're taking more business risk. Okay, our next problem starts off with the magnitude of operating leverage for XYZ Company is 3.6 when sales are $240,000 and net income is $40,000. So right now their operating leverage is 3.6, which means that every time sales go up $1, then income goes up $3.6. Now, here's what they want to know. If sales decrease by 6%, net income is expected to decrease by what amount? All right, let's set up what we have here. Sales, net income, operating leverage. Currently, our sales are $240,000, our net income is $40,000, and our operating leverage is 3.6. If we decrease our sales by 6%, what's that going to do to sales and income and so on and so forth? So if we take 6% of $240,000, that looks like 6% of 240 would be a decrease of sales of $14,400, and that also looks like it would be 6% of 40,000, which is $2,400. So the question is that right? If we decrease our sales by 6%, will sales go down 6% and income go down 6% when our operating leverage is 3.6? The answer is no. So when our operating leverage is 3.6 and we have a 6% decrease in sales, then profits are going to go down 6% times 3.6, or they're going to go down 21.6%. So you can see we have a huge drop there if we have a lot of leverage. So that means if our profits were, our income was $40,000, then we're going to take 21.6% of that, and that's how much our decrease is going to be in net income. Not $2,400, but $8,640. So our leverage doesn't change, and the new levels of sales would be 240 minus 14.4, or $225,600, and our new income is going to be $40,000 minus 21.6% of that, which is $8,640, which means our net income is going to end up being $31,360, and of course there's no change in the leverage. So decrease in net income is going to equal the net income times the percentage decrease in sales times the magnitude of operating leverage, which in this case was the $40,000 in income we had times the 6% change, which was a decrease, times 3.6, which is a leverage amount. And so 8640 is how much income is going to go down. That's the answer you're looking for. Okay, our next problem deals with, they want to know what's the operating leverage for this company when they give us sales of $850,000, variable cost of $388,000, contribution margin, which is $462,000, and fixed costs, which are $138,000, and income of $324,000. So we know from past examples that the operating leverage is going to be the contribution margin divided by net income. That's going to be sales of $850 minus variable expenses or variable costs of $388. That difference will be divided by the $324,000 worth of income. This means that contribution margin was $462,000 divided by $324,000, which was the net income, and our operating leverage was 1.43. That means every time that we have $1 in sales, we have $1.43 that goes towards profit. And our next problem, XYZ Company currently produces and sells 43,000 units of the product at a selling price of $13. The product has variable costs of $5 per unit and fixed cost of $53,000. The company currently earns a total contribution margin of what? So what's our total contribution margin? Well, total contribution margin is the selling price minus the variable cost. These are per unit numbers, and that difference is multiplied by the total units that they sold. So we can take $13, which is the selling price, and $5, which was the variable cost per unit. That difference is $8 a unit. That's the contribution margin, times 43,000 units that they sold up here, right there, and that would give us a total contribution margin of $344,000. So like I said, that's the contribution margin of the difference between the selling price and the variable cost per unit, which is $8, times 43,000 units, which is a total contribution margin of $344,000. This problem starts off with XYZ company produces a product that has a variable cost of $6 per unit. The company's fixed costs are $42,000, and the product sells for $12 per unit, and the company desires to earn a profit of $21,000. So what is the volume of sales in units, not dollars, but in units, required to achieve the target profit? Remember, that target profit is $21,000. The formula for this would be fixed costs plus the desired profit. Those two are added together, and you divide that by the contribution margin per unit. And that'll give you the total sales volume in units you got to have to make that desired profit level. So you take $42,000, which are fixed costs, add to that the profit you'd like to make, which is $21,000, and now you got to recover all your fixed costs, and you got to recover all of your desired profits. So that looks like a total of $63,000 that you got to have there. And the way you do that is to sell units. And when you sell a unit, you're selling it for $12, and your variable cost for that unit is $6. So every time you sell a unit in this situation, you're making $6. So how many units do you have to sell in order to recover all these fixed costs plus make that profit of $21,000? So you're trying to you're trying to achieve all your fixed costs being covered plus your desired profit, which is $63,000, and you're doing that by trying to sell units that you end up making a profit on, or a contribution margin on, of $6. Every time you sell one of these, you get $6. So you divide that $6 into the $63,000, that means you're going to have to sell 10,500 units to recover all of your fixed cost and also to make your desired profit level of $21,000. Okay, this is our last review question here on this review, and this is a little tricky because it's making you think a little bit. This question starts off with XYZ company has not reported a profit in 5 years. This year, the company would like to narrow its loss to $15,000. So they're just hoping to get a loss that's no more than $15,000. Assuming its selling price is $36.50 per unit and its variable cost per unit is $24, how many units must be sold to achieve its target? And remember, the target is just to have a $15,000 loss, given that total fixed costs are $60,000. Well, this little formula is going to be the same no matter what your target is, but to understand this problem a little bit better, hopefully, we're going to start with, let's just say if we can say, all right, instead of having a loss of $15,000, let's just see if we could break even, okay? So to break even, to find out how many units you'd have to break even, you take fixed costs and you divide by contribution margin. So in this case, you'd have fixed cost of $60,000 divided by the contribution margin of the selling price, right, minus the variable cost, and that looks like that's going to give you $12.50 contribution margin. You divide that into 60,000, and in order just to break even, not to make a profit, and not to narrow your loss, but to break even, you're going to have to sell 4,800 units to break even. Now, that's not their goal. Their goal is to just narrow their loss to 15,000. So here's what we're going to do. We're going to do the following. We're going to say, okay, fixed cost plus the desired profit, and in this case the desired profit is really a $15,000 loss, which is kind of backwards, but that's what we're going to say. And we're going to add these two things together, and we're going to divide that by the contribution margin per unit. So we're going to have 60,000 in fixed costs minus 15, so we're only going to recover $45,000. That's how much we're going to recover by selling these units. So that $45,000 is going to be divided by the contribution margin per unit, which we set up here was $12.50. So that means that if we take the $45,000, that's our goal, that's our level of desired, in this case our target rather, We're not going to recover the full $60,000 in fixed costs. We're going to just narrow our loss to $15,000. So therefore, we're going to put 45 in here, divide that by 1250, and we end up selling 3,600 units. So that makes sense. So if we could sell 4,800 units and break even, then selling 3,600 units wouldn't get us to break even, but it would get us to our goal, which is to narrow the loss to 15,000. And that's the end of this review.